Now, in the middle portion of the periodic table, we did not assign charges to these. And that's because these have variable charges. And there's no real need to memorize what the charges are, because if we were to encounter one of these in a chemical formula, we would encounter it something like this. If we saw this ion, the iron 2 ion, we would know that its formula is Fe with a 2 plus charge. And if we encountered something that has a name of iron 3, then we know that we're dealing with iron with a 3 plus charge. Now these numbers up here, hopefully all of you know how to write out these numbers as Roman numerals. These Roman numerals are equal to the charge that's on the ion itself. So if we had seen something like Cu with a positive charge, or Cu with a 2 positive charge, the first one here would be called?
Cobalt?
Not cobalt.
It's copper.
Copper. Followed by? Yeah, not 1 plus. 1 in parentheses, or Roman numeral in parentheses. And Cu with the 2 plus charge would be? What do we call this one?
Copper Roman numeral 2.
And this one would be copper 2. So the names we use are iron 2 and iron 3. This would be copper 1 and copper 2. Now there's no need to memorize what these are, because if you look at the Roman numeral, again, that will tell you the charge. Likewise, if you know the charge, that would tell us what the Roman numeral is here on the name. Now this goes back to a problem we used to have with how these things were named. The way these things were previously named is that this first one was called the ferrous ion, and the second one here was called the ferric ion. And in the case of the copper 1 and copper 2, this first one was called the cuprous ion. The second one here was called the cupric ion. Now the problem with these, well, first of all, where did these names come from, the ones in red? They're from the Latin names. And if we look at what the naming scheme is here, the lowest charge form was the one that had the OUS suffix on it, and the one that had the highest charge had an IC suffix on it. Same is true here. Lowest charge is OUS, highest charge is the IC suffix. The problem with that is there would be some confusion, because you'll see here that the one with the 2 positive charge has an OUS suffix, whereas the one with the 2 positive charge here had the IC acid suffix. So they were often confused with each other, plus it meant having to memorize all of the formulas and charges for all of the ions. So this naming scheme that we have here now is one where we simply don't need to know any of the charges on any of these in here, but we do need to know that they do have variable charges. So again, that's what we do need to know, is that they have variable. I have tried to color code this here by showing the ones that have fixed charges in blue and the ones that have variable charges shown in red. When we talked about these 3 plus and 3 minus charges on here, actually the 3 plus charge really only applies to the aluminum that's in here, which is the metal, and the 3 minus really only applied to the nonmetals of this group. Because the metals have positive charges, the nonmetals have negative charges. But if we go back to the sheet of ions, which now I don't have up here, but if you go back to the sheet of ions that I just passed out for you here, you notice that there are some polyatomic ions listed on the left-hand side, And then there's some common metal ions that are listed on the right-hand side of this table. And if you look at the ones on the right-hand side, you'll see that those elements include zinc, cadmium, and silver. That is, those three elements right here. And that is because these three elements actually have fixed charges. So again, I'm showing them here in blue to indicate that the charges on these are fixed. The silver, according to your sheet there of ions to memorize, has a charge of 1 plus. The zinc and cadmium that are on that sheet have a charge of
3 plus?
not 3 plus, 2 plus. The charge is 2 plus. So again, silver is a single positive, zinc and cadmium each have a 2 plus charge. And then over these here where it appears as if these would all be fixed, there's actually a number of these here which have variable charges. And I'll once again color code these. These here also have variable charges in addition to the transition elements. So when we see these ions, any of them here that I've labeled in red, we see any of them written in compounds, they must include a Roman numeral in their name to indicate that their charges are variable and to indicate which charge we're talking about. So, if we were to apply this and we want to write out a chemical formula, let's say that we want to write out a formula for something like iron 3 oxide. Iron 3 oxide. Well, to write out this formula, we need to know the charge of the iron 3 ion. And that's going to be Fe. The Roman numeral 3 tells us the charge is 3 positive. Oxide will be one that we determine based on its position in the periodic table. So here we see oxygen, so its charge there would be
2 negative.
2 negative. So if we have a 3 positive and a 2 negative, we now would like to balance the charges between these two. So to balance these charges, one of the ways is to find the least common multiple between these. So, and that is between absolute value actually. Least common multiple between 3 and 2 would be
6.
6. So how many of these iron ions do we need to get 6 positive charges?
Another one.
Yeah. And how many oxides do we need to get 6 negatives?
3.
Mm-hmm. So now if we want to write out that chemical formula, remember the formula is a count of the number of each, so the formula would be Fe2O3. Then if we wanted to write the formula for something like iron 2 oxide, iron 2 would include Fe with the charge of 2 positive. Oxide is O with a charge again of 2 negative, as it always has a 2 negative charge. So the formula here would become
FeO.
FeO. And again, that comes from the fact that we want to balance the total of the positives here with the total of the negatives. We might have a formula or name like this. Titanium. Let's see how well you know your Roman numerals. 4. So titanium 4 sulfide. Come up with a formula for titanium 4 sulfide. What would the charge on the titanium be? 4 plus. Sulfide would be S with a charge of
2 minus.
2 minus. Well, this one's probably easy to look at in balancing charges. How many titaniums do we need?
1.
How many of the sulfides?
2.
2 of them. Good. And then the formula becomes TiS2. Again, remember that the final chemical formula is always written here without indication of charge. Now, if you have any questions, just stop at any point. Otherwise, if we keep going, our examples today are going to get increasingly complex. So, again, at any point, if you have questions, just be sure to ask. Let's say we have CuO and Cu2O. We want to write out names for these two. Well, now before you write out the names, one of the things we should realize is where copper is located in the periodic table. And it's going to be located right here, which means its charge is variable. And if its charge is variable, that means that the name must include
Roman numerals.
Roman numerals. So, without the Roman numerals, let's just write the names without the Roman numerals. Each of these would be called
Copper oxide.
copper oxide. Good. And then our job is to fill in those Roman numerals. So let's go ahead and do that. I'll give you about a minute here. Check with your neighbors. All right. Let's start with the first one here. This would be copper
1.
1, 2. Anybody have 3? This one here is copper 2. The next one, Roman numeral would be 1. Any others?
1.
1. All right, now to get these, here's how we go about this. We kind of work backwards on these. What we have to remember is that the charge on the oxide is always equal to how much? 2 negative. So its charge is 2 negative, and we look at this formula here, we see how many coppers?
1.
Just 1. So that must mean that the charge on it must be 2 plus. If its charge is 2 plus, that gives us here the Roman numeral of 2. Once again, if we go at the second one, oxide always has a charge of
2 negative.
2 negative. If we look at this formula, though, we see how many coppers?
2.
2. So if we have 2 coppers and the charges must balance, that must mean that the charge on each one of these is
1.
1 positive. We take that single positive, and that gives us a Roman numeral of 1. So what's important to remember is that the Roman numeral does not come from the subscript here. The Roman numeral comes from the charge. It's determined by the charge that's on the ion, not in the subscript. So something like this, students often confused because they're looking at that subscript and not at the charge on the ion itself. So any questions on these here? Yes? One more? Sure. Let's say that we have something like this one here. We have CrBr3. Now if we want to come up with a formula for this one, we do know the charge on bromine. We can go back in the bromine and see that the bromine has a charge of
1 negative.
1 negative. So since its charge is 1 negative, and we have how many bromines here now?
3.
3. And so these 3 bromines add up to a charge of
3 negative.
3 negatives. And then we have how many chromiums here? Just 1. So in order to balance charge, that must mean that the chromium here would have had a charge of
3.
3 plus. So the name of this then would become chromium 3 3. That's right. We need that Roman numeral 3 in there. Chromium 3 bromide. Any others?